Okay, 1.6. Number 3. So if the inverse takes -4 back to -8, then the original function must have taken -8 and made it be -4. If f of 5 is 2, the inverse would take 2 back to 5. But this is the function of 5. Well, we know that's 2. And notice this is not inverse. It's going to be 2 to the -1, which means we're going to do the reciprocal of 2, which is 1/2. Okay. We have graph of f of x, f of 0. So if x is 0, y is 3. Now it says, when y is 0, what is x? Y is 0, x is 2. This says the inverse. So this is a y value. The y is 0. What was the x? 2. So this is asking the same question as this. If y is 0, what was the x? 2. And this says, if this is the y and we end up with x being 0, y is 3. So x here is 3. 3 going backwards, 3 for the y takes us back to 0 for the x. Use the table to solve these. F of 1. 1 is 0. What value of x gives us 0? Well, what value of x gives us 3? 3 comes from 7. X would have had to have been 7. F inverse of 0. So if f gives us 0, x was 1. This equals 1. And so this would have been f of 7 equals this number in here. Remember, this is backwards, so this is really the y and this is the x in the original function. So x is 7, it's 3. Okay. 15. Find the inverses. Well, the rule I gave you in class, change the function to y. Swap y and x's. Solve for y. Multiply by -1 to get rid of that negative. And we get -x plus 2 equals y, and that would be f inverse of x. This would undo what that does. 19. So find a domain which is 1 to 1 and non-decreasing. Well, this is a parabola. 19, I'll draw this one here. That's moved 7, 1, 2, 3, 4, 5, 6, 7 to the left. And we want it to be non-decreasing. So 0 and increasing. So we would use this part of it. Notice that the function passes the vertical line test, but it wouldn't pass the horizontal line test, and so it wouldn't be 1 to 1. But if we drop this part of it, then it is 1 to 1. And so we'd want to find the inverse of f restricted to that domain. So we've got to find the domain that makes this happen. That would be from, the domain would be from negative 7 to infinity, including negative 7, and its inverse, so we're going to go y equals x plus 7 squared, swap y and x, solve for y, so square root, that's going to be plus or minus, but we're going to use only the plus one. And the reason we're using the plus one is because what happens here, the inverse is going to be, this one would go, it would go this way, and we want to use plus the square root. We want to use the upside of these, not because that's the part that matches this. This part matches this. So we want to use the plus sides. We use plus this, subtract 7, so we get minus 7 plus the square root of x is the f inverse of x. Minus 7 plus the square root of x. The square root of x is this side of the parabola, move down 7. Okay. 21. Let's do that on this. 21 is f of x equals x squared minus 5, which is a parabola. Move down 5. 1, 2, 3, 4, 5. Goes over 1, up 1, over 1, up 1. Looks something like this. Okay, so if we want to do non-decreasing, we'd want to use this side of it. So our domain would be restricted from 0 to infinity. And we'd write y equals x squared minus 5, x equals y squared minus 5, add 5. Take the square root, and it would have been plus or minus, but if we're using the non-decreasing side, and we flip it over, so this is 0 minus 5, so it'd be minus 5, 0, and this would go this way. It would be the reflection over this line. And this is the plus side, so we want to go up. This is the square root of x function. Move this way 5, which is what this says. Move to the left 5, the square root function. And 23. If f of x is this, and we're going to put this in for x, g of x in for the x's of f, so we get f of g of x. Boy, I hope I did this one in where you could see it. Equals f is x, which we're putting in g of x, cube root of x plus 5, cubed minus 5. Well, cubing the cube root gets rid of it, so we got x plus 5 minus 5, which is x. What this is saying is if I put something into g, I will get a new number, but if I put it into f, I'll get back to what I started with. I start with something for x, it'll change it to something, and then the f changes it back to what it originally was. That means f and g are inverses of each other. To confirm that, we can put f into g. So we'll put this in place of the x of this. So we're going to have g of f of x will look like the cubed root of, in place of the x, we're putting x cubed minus 5, and then we have plus 5. So this is what was x is x cubed minus 5 plus 5. The minus 5 plus 5 cancel. The cube root of x cubed is x. Once again, if you put a function inside another and you get x, what you put in is what you get out, then that tells you that they're inverses of each other.